Station, this is Houston. Are you ready for the event?
Houston Station, I'm ready for the event.
Motherboard, this is Mission Control Houston. Please call station for a voice check.
Station, this is Motherboard. How do you hear me?
I've got you loud and clear, and I'm ready for your questions.
Great. Thank you so much for taking my call. So I wanted to talk to you a little bit about BEAM today, and I was wondering if you can describe what it was like entering it for the first time.
Well, BEAM is one example of new technology, of course, being brought to the International Space Station to prove out that new technology. And of course, so it was a first. It was a major first, a first in terms of its design concept, and of course, certainly on board the International Space Station. So, like many firsts, many milestones, it's exciting to be part of it, and I was honored to have that role, to be able to enter it and outfit it and get it up and running for its time here on station.
Great. Can you describe the inflation process for me?
Well, the inflation process was, we used a small amount of air to get a small amount of pressure to inflate it, and it had some rip stitching inside and a mechanical device that would control the inflation. So we inflated it just a little bit at a time to try to get it fully deployed before we really pressurized it. It took a little bit longer, as you know. It took we did not get it inflated the first day, and we came back another day after the ground team spent some time looking at it. It took a little bit more force than we expected to get it deployed, but it deployed eventually, and it's in a nominal configuration. And again, it went very well after that first day's scrub.
Great. Now, is the air inside the beam any different from the rest of the station, temperature-wise?
When I first went in, it was a little bit cooler, and that's just because we didn't have climate control going on in there, and that was predicted, and it wasn't uncomfortable or anything. It was just a little bit cooler. It also had a new car smell, as you might expect, with the new materials that hadn't been exposed to the wear and tear of life on board the International Space Station. And one of the first things that I did is I got ventilation up and running, so we were exchanging air between the International Space Station and the beam module. So it quickly, the new car smell quickly went away. So other than that, there was no significant difference.
Great. Now, is a habitat module like the beam any more or less sensitive to things like micrometeorites or space debris?
Well, I'm not totally familiar with the technology that's in the beam design, but I'm certain it includes design concepts which would be a protection against micrometeorite hits. As you probably know, we're not leaving the hatch open. It's closed, although we do have ventilation going back and forth through hoses between the station and beam, but we're keeping the hatch closed. Its design concept is much different than station. I trust it has protection, but how that protection compares to the International Space Station, I really can't speak to.
Okay, thank you. How do you think a module like BEAM will affect the future of living and working in space?
Well, as you might know, it took almost 40 space shuttle flights, I think 37 or 38 space shuttle flights to support the space station assembly over many years, and it took an equal amount of Russian rocket launches to get the Russian part up here and then to put it together. That's a lot of rocket launches. And when you launch something on a rocket, you want the volume that you're launching, the spacecraft that you're launching, you want it to be volumetrically efficient. So you want it packed just as full of things as you can. However, for a spacecraft that is going to have people, a crew living on board, you need open volume like you see here right now for the crew to live and work in. So we launched a lot of open volume on the International Space Station just by virtue of the requirement to be able to live and work on board this orbital complex. The beam concept gives us the opportunity perhaps in the future to launch components of spacecraft or habitats or whatever you might imagine for a habitable destination in space, to be able to launch it volumetrically more efficient, and then to inflate it later to get the volume you need, the open volume inside for the crew to live and work.
Great, thank you. Now, I know that you shared a really nice picture of the strawberry moon the other day taken from the space station. How do you feel that social media has changed the business of being an astronaut?
Well, you know, what we do up here is, we think, is of value to the public, to the people of the United States and the partnership and entire world. And one of the things we've struggled with in the past is getting the word out that we're flying and what we're doing on board the space station. After the space shuttle retired, or since it retired, I often get questions out in public settings that, well, I didn't know we were flying. We're still flying. And I say, yeah, we've had continuous human presence for over 15 years, 15 and a half years now on board the International Space Station. And the public was largely unaware of it. So social media is a great means to keep people aware of what we're doing up here. So has it changed the life of an astronaut? Certainly. It gets you certainly more in touch with the public. We're largely unknown nowadays, unlike the 1960s, because of the coverage. The coverage is different, right, and the public attention is different. And unknown is okay, but social media is obviously making the crews known, as well as what we're doing up here, and by virtue of that, making the entire international partnership known to the public at large.
Great, thank you. Could you talk about briefly about a couple of the science experiments that you're working on right now?
Well, I just outfitted an experiment in the Japanese module this morning to go in the airlock, to go outside and spend a fair amount of time outside. It's it's got different kinds of materials and whatnot that is going to be exposed to the environment of space outside for a period of time and then brought back in the future. And then scientists on the ground will study those things. That's one example. We do a variety of experiments up here, as you know, across the whole spectrum of science disciplines, from material science to biological science, plants, animals, bugs, microbes. Probably the most interesting and the broadest study area that we have up here on board the International Space Station, though, is the study of the human body and the effects of the weightless environment and the space environment on the human body, which is very important, so that we can understand those effects, develop mitigation for those effects to support future exploration wherever we go beyond low Earth orbit.
Great. Thank you so much.
You're very welcome, Amy. Good talking to you.
Station, this is Houston ACR. That concludes the Motherboard portion of the event. Please stand by for a voice check from CBS News.
So you and Alexei and Oleg are going to have the station to yourselves for another week or so. Between now and the arrival of your next crewmates, your Russian colleagues are going to test the Toru navigation system, or the rendezvous system, on the Progress 62 vehicle. I'm wondering if you could tell me a little about that test and why that's important to you guys.
Well, as you know, on the Russian side, they've been upgrading the Soyuz and Progress periodically over the years, and this is part of a test of that latest upgrade. Very important. The last couple of Progresses have been the modified version of the Progress, which is, in terms of its navigation capability and its guidance to rendezvous with the space station, is a big step forward from what they had previously. And the Progress sort of runs pilot flights, if you will, ahead of the Soyuz, and this next Soyuz is going to use that upgraded system. So this test is supporting the operational development, if you will, of that upgrade of the new guidance and navigation control system of the Progress and Soyuz families of vehicles. So very important to get it right. Obviously, when we're doing new things like that, sometimes we miss something now and then, and that's why we do those testing, just to catch those misses and to get them corrected as efficiently as possible.
So I guess it'll be a manual docking of the Progress, and then if that goes well, you'll welcome 3 new crewmates on July 9th with that new Soyuz MS vehicle you were talking about. Other than the rendezvous and nav sort of upgrades, what other safety improvements, or maybe they're not safety related, but what other improvements are you looking forward to in the new MS series of the Soyuz?
Well, like I said, it's got a modified control system and guidance and navigation. It will get its state vector from the equivalent of GPS, the Russian equivalent to GPS. So it doesn't require ground passes over ground sites in the greater Russian area like previous vehicles. So that makes the vehicle a little bit more robust in that sense, and it's just it's a big step forward. It's got more digital capability, and of course, as we know, as we've been adding computers to all sorts of things that everybody works with in life, that gives greater capability. So it's just a normal progression, step-by-step advancement of technology and performance for that vehicle.
Well, shift gears a little bit here. I know you're probably getting tired of questions about the Bigelow Expandable Activity Module, or BEAM as it's known, but let me throw one or two at you. I'm just curious what your impressions were when you went inside and what your thoughts are about that technology in general for perhaps making station modules more affordable or habitat modules for deep space missions, more of a reasonable proposition. I mean, just what your impressions are.
Well, I was honored to be part of that operation, to be able to go in the beam and to get it outfitted for its time on the space station. Going in, of course, it was like entering a new car. It had that new car smell. The air was a little bit cooler than on board the space station, but that's because it wasn't environmentally controlled, and it was as predicted and not uncomfortably cool, just noticeably cool. I think it is a concept, a design concept that holds great promise to be able to more efficiently launch elements of a spacecraft or habitats going to a surface of another body, for example, on using fewer rocket launches, volumetrically efficient. That is, when I'm floating in here inside the laboratory module, when this thing launched, it's big, and it launched on the space shuttle, which of course is very big, and it took many space shuttle launches to get the space station up here. And we want to volumetrically use everything we can on a rocket launch. But this wasn't filled. This was empty space, so we were launching empty space. So the concept that the beam uses, inflatable, means that you can launch more volumetrically efficient and then inflate components to get that habitable volume that you need for crews to live and work.
And again, changing the subject just a little bit, looking ahead to the next SpaceX launch, of course, you got a docking adapter on board, and I guess you and Kate Rubins will be installing that somewhere toward the end of August in a spacewalk. How are your spacesuits doing? Are they now ready to go, given these recent issues you guys had with some unexpected water buildups?
Well, as far as I know, we're on track for the spacesuits to be operationally ready to support those spacewalks that we plan on doing in about the August timeframe. I just completed routine maintenance on all 4 spacesuits that we have on board, and that went well. So far they're holding up. As you know, we've had some issues over the last couple of years, and the teams on the ground have done a stellar work to work through those issues to make sure that we have that capability. It's a capability that's very critical, of course, to supporting the ongoing life of the space station.
Hey, we're getting ready for the July 4 holiday down here, and since you're the only American on board right now, I don't suppose there's much you're going to do to mark the event in space, but will you at least get some time off?
Yeah, we'll get a little bit of time off. There's never a day here that's truly completely off. There's always things to do, but it's nice to have a day that's mostly unscheduled, so you can spend the time doing the things that you want to do and also do a little bit of personal time. And of course, so I'll be doing that on July 4th. I'll be communicating with friends and family on the ground to participate with them in celebrating the holiday. And also, even though I'm the only American on board, in this international partnership, we tend to celebrate each other's holidays together and to support each other in that effect. So I expect good support out of my Russian colleagues on the 4th of July.
Hey, thanks. You know, one of my radio colleagues was wondering if astronauts can ever see fireworks from up in space. And I realized that, you know, the timing is everything. You got to be over the States or something. It's got to be nighttime. You got to be awake, et cetera, et cetera. But have you ever heard of anyone ever seeing fireworks from space, or do you even think you could?
I do not recall a case where somebody has been able to see it. I was up here on a previous 4th of July, and I did spend some time trying to get a sighting on fireworks, and I was not able to do that. And obviously, as you said, the lighting and or the timing is very important. You got to have clear weather. It's got to be night going over the U.S. And then you have to be able to go over the spot where you can spot the fireworks. Depending upon our timing, this time I'll certainly be looking out the window if we're over the U.S. at nighttime to see if I can do that this time.
Hey, one last question, Jeff. You know, Scott Kelly logged 520 days in space on his 4 missions, and you're going to exceed his record, I think, on August 24th. And when you land in September, I think you move up to number 14 in the world or something like that. Is there any significance to records like that in your mind, or is that just something that comes and goes for you?
For me, it mostly comes and goes. The numbers don't really mean that much to me. The content of what we've done, I think, matters more. And when people ask me about that in my career, I immediately think about the space station itself. And I've been honored to be from end to end, from the very beginning of the space station involved, and then through midway in the assembly, and then assembly complete, and now on the full utilization of the space station. I'm more honored by that than the total time that I've been up here. And it also is a testimony to the international team that made this orbital outpost so incredible and possible.
Thanks, Jeff. Appreciate it very much. Have a great rest of your flight and look forward to talking to you down the road.
Thank you, Bill. Great talking to you today.
Station, this is Houston ACR. Thank you. That concludes our event.